Good morning, Jess. This is me. This is your Homework 8 review video. I kind of like making these videos, and I hope that they are helping you guys learn. All right, so two-way Anova. That means two grouping IVs. So the first grouping IV is who the manager is. Three levels. Level 1 is Marty. Level 2 is Juan. Level 3 is Tammy. And the second IV is just a 2 level, whether they had training or not. So you had to do this by hand. Sorry about that. And I'm hoping that you noticed that the mathematics wasn't really that bad. I think the hardest thing you have to do is square a bunch of numbers, add them up. They're just long, and boy, do I know it. All right, let's get started. So what are the null hypotheses? There's no significant difference between the sales managers and the number of sales, right? That's the DV. Sorry, the DV is the number of sales. Right, that the manager doesn't make a difference, nor does the training make a difference. The alternative says, yes, there will be a difference in there somewhere. So I'm going to look at your APA write-up, a two-way Anova. Normally, for me, I always say with no repeated measures. That was just the way I was taught, but I don't think that's very important, but you can think about it. So a two-way Anova was run to test if there was a difference between sales and managers and the training. Yeah, good. Da, da, da. So data showed managers did not have did not have an effect on sales, right? That's the main effect of the managers. So there was no main effect of managers. And that's the number I got, pretty darn close. You're right, and it's not significant. Perfect. So as for the training and programs and sales, the null is rejected. Yes, I agree. And there's a significant difference. Good. Training programs, the F of alpha 0.05 at 1 comma 24 is, my number was a lot bigger than that, but I still got the exact same probability value. So I'll look through your stuff here in a second, see what's going on. And there is also a significant interaction. Boom, boom, boom. Good. That one's good. So the only one I'm worried about is the training program one, but I'm going to take a look, so please hold. Okay, let's look at your ANOVA table, shall we? I'm just going to turn my head here. Oh, there's your F right there. So you did get it right. I think you just copied it down wrong. Right? This is your F for your between groups. Boom, boom, boom. For variable B, which was the training. Yeah, that's almost exactly what I got. So I think that you just copied it down wrong. So, right, this first F is for the managers. That was variable A. The second one is for variable B, which was the training, and this was the interaction. So, yeah. So, no, you did good. Hold on. All right, let me look at your calculations here. Yep, A has 3 level, B has 2, N is 5, right? That's how many in each little group. Oh, you drew the estimated margin means here, right? You can see how they cross. That means there's going to be some kind of interaction in there. And your sums and your bracket A, bracket roll. Whoa, my goodness, look at you. All right, so that's perfect. You did perfect. I am very impressed with your work, young lady. And that will be the last one you have to do by hand. Okay, so congratulations. All right, I'm going to look at part 2. Sorry, question 2. Okay, here's problem number 2, homework 8, and your calculations are correct, but I'm not seeing a lot of stuff here. Like when you say there's a significant difference, I don't see the F, at 0.05 parentheses 2 comma whatever it is 36. I'm not seeing those, so you need to put those in there. And some of your conclusions aren't quite right. Plus, whenever you write the mean, right, you also have to put comma SD, standard deviation. That is APA formatting, so you just can't write the mean equals this. You also need to include the standard deviation. They get real picky, those guys. But I'm going to look at your SPSS tables. So right off the bat, when you send me your SPSS tables, I don't really need this code, okay? But I can look at it and say, yeah, you ran a univariate ANOVA, right, with the DV, and your variables are A and B, very clever. You ran a Tukey test. You did some profile plots for interaction, which is good. Tables, you look for power, at a squared, homogeneity of variance, descriptive statistics, with the critical alpha set at 0.05. So you're good to go. Let me look at this. Okay, again, I don't need this first output box from SPSS. Blah, blah. It just tells me when the file was dated, etc., etc. But this is a good box to include. Tells you how many people are in each little subgroup. Descriptive statistics, right. These are the means and the standard deviations that you would write up with in APA formatting. So I'm looking at them right off the bat. I can already tell that see how much bigger these are than the rest of them. Okay. So it looks like the interaction is going to be between commission and something else. Possibly, we're going to let the SPSS do the talking for us here. There's your Levine's test, so it did not violate the assumption of the homogeneity of variance. And here's your money box right here. Okay. So let me try to explain this to you. So the overall model says that yes, there was a significant difference somewhere in auto sales between the incentive packages and the benefits packages. So your first variable was the incentive packages, right? Stock options, more retirement. And there was a significant difference in there somewhere, right? That's what this says. Now your other one was your B. Let me see which is which. Hold on. Okay, you ran the SPSS perfectly, okay? So there was no significance between B, and that was the financial incentives. There was a significant difference between A, and that was the benefits packages. And there was an interaction in there somewhere. So that part is exactly perfect, okay? Looks like you're really good at SPSS. Good. It has the power. Good. So keep the boxes with the power, right? The power is really strong. Except for B. Okay. B's not that good. But the other ones are good enough for me. So I don't need the grand mean. Here's your Tukey test table. So this is the benefits box, right? So there is a significant difference, according to this, between stock options and commission. Commission and stock options. But now remember, I'm sorry, this is the financial box, right? The financial incentives. But because there was no main effect overall for the financial incentives, we wouldn't look at this Tukey test under finance. Okay, we would only look at it, the one that had a main effect, and that would have been the benefits packages. Okay, I'm getting my A's and B's all mixed up here. But this is the one. No, this ain't the one. Don't need this one. Here we go. So this is the one with the incentive packages. You'll notice there's no significant difference anywhere here. Okay. So remember, if there is no main effect, we really don't need to look at the effects of whatever that variable is, because that means the only thing, if there was interaction on that side with that variable, it's because of the interaction effect. So that's what we see going on here. And let me look at your profile plot. Good. Here's the estimated means, and you can see there's tons of interaction all over the place. So you did very, very good. I'm going to have to ding you a couple of points for not putting in your F, parentheses, equals, that kind of stuff. But I also turned on the example write-up sheet, so I want you to look at that as well. So overall, you did very, very good. I'm very happy with your progress. Keep up the good work. So now start on homework 9, and stay tuned. I'm going to send everybody a video here in about an hour or two for this week's homework assignment. MGZ, out.